Hello, everyone. So, good day to get going on SOHCAHTOA solving for angles. So, continuation of the sine, cosecant stuff from yesterday, or the previous lesson, I should say. Yeah, and we're going to solve for angles now. Just before we get to that, let's do a little review of the material from the previous lesson. So, just solving for our missing side. And remember, the key thing to do to help yourself get this right every time is to identify that hypotenuse. Even if you're not going to use it, it's kind of good to identify it because then you end up identifying this side correctly. This one here, because if the hypotenuse is here, then this must be the adjacent side because it's beside it, but there's two sides that are beside it. One's hypotenuse, one's the adjacent. Adjacent literally means beside. Your neighbor lives adjacent to you is the way the language would work if you use the word normally. And way over here on the opposite side of the triangle, so I might just get rid of the arrow for the opposite to the 90 degree there, so we can focus on the opposite side to the 40 degree. So that means we have opposite and adjacent that we are using and have, or looking for and have. And so the normal process. Get your stuff acronym or word, whatever you want to call it, and you've got opposite and adjacent. So opposite and adjacent, the one where you have two is the one you use. So we're going to say the tan ratio or the tangent ratio of the 40 degrees will equal the opposite side over the adjacent. So we just need to calculate the tan of 40. Make sure to calculate in degrees. Have 0.839 or so. Does keep going. You can keep more or less. Doesn't matter. At this stage, keep bunch and at the end round reasonably, right? Reasonably meaning like set about 4 inches, right? So you're not going to keep 7 decimal places. Just makes sense. So we have that, and then we multiply both sides by 4 to get rid of that divide by 4, just like that. So I'm multiplying all the decimals the calculator had by 4, giving me an answer of 3.356 ... You know, there's lots of decimals there. If we're going to ground to say 1 decimal place or so, because presumably this was like 4.0 approximately inches. So now we're talking about 3.4 inches really. 5 up in 3 and 3.4. Actually, a special rule to do with rounding 5s, and it's this digit will always be even. So if this was a 3.6 or something, you would just leave it as a 6. Curious about higher end rounding rules. Banks use it so they don't round up more often and give you more money than they want to count. There's one more up rounding, right? With the 5 situation. Not a problem. If you have questions, let me know. And the next one here, again, let's label that hypotenuse. That's the longest side across from the 90 degree. We're actually using in that one this time. And the adjacent side, the one that's beside it. So in our SOHCAHTOA, and again here, we're going to identify that we have the hypotenuse and the adjacent, right? It's a hypotenuse and adjacent. And so cosine stands out. We use cos of 30 degrees equals the adjacent side, the hypotenuse, which was A. So notice that this is the one where we were solving for the number at the top, so it's a simpler process. And this one we're solving for that number that's in the bottom, right? A equals is our goal, and it's stuck there in the bottom before we have to algebraically fix it. So cosine of 30. Cosine of 30, just do it in a calculator, you get 0.866 ... 22 over the A. And so to solve this out, I didn't show it before, maybe I'll show it this time as well. Instead of just the one method, but the one method here is to multiply both sides by A. And a lot of people would write it as like 0.866 ... whatever A and then equals the 22.5 there. And then we would divide out that 0.866. So I'll be on the bottom part of the smartboard here. Dividing out 0.866. That leaves me with 22.5 dividing by all of those decimals the calculator gave me is 25.98. 8 dot dot dot. So really, you know, the 8 would round to 9 up, so that's going to round to 5 up. So we're looking at about 26, I guess, for that one. This one back here was in inches. So we could say like inches like that, or write the word. This one was in meters. So I feel like, yeah, pretty much because we're rounding the 8 up, like if they wanted to do a decimal, it would be actually decimal 0 meters to sort of match the decimal level that was going for precision and measurements to the start. All right, well, that's just a review of solving for missing side. And so moving on to solving for angles. So the first thing we need to know is if we're solving for angles, we're going to need to use a different button on the calculator. The buttons we've been using, sine, cosine, tan, give you what sine, cosine, tan of an angle is. Here we have what sine, in the first example here, we have sine of A is equal to, right? And so sine of something gave 0.5, if you think of it that way. So what we're going to need to do is we're going to get rid of the sign. We're going to undo that sign process, that button on the calculator that, you know, gives you that ratio of those sides. So we're going to need to do, we're going to undo it. And so to undo it, it's called the inverse function. And so right here, the inverse function. And so the sine inverse, it looks like -1, sine -1. It undoes sine, cos inverse undoes cos, and tan inverse undoes tan. So the undo process in your calculator can have sort of 3 different words I've seen that describe it. Some say INV for like inverse. So you get inverse and then sine would change to be sine -1. Right? So if you did INV sine, then it's the same as sine inverse. Or you do shift and sine, or you do second and sine. For this on your iPhone or device, Apple, at least anyways that I use, you have to turn the calculator. If you logged in, you turn the calculator sideways. And for them, it says second. So iPhone says is second. The calculator that I have, it's a Sharp, says second as well. There are some that say shift and inverse. So it's not in my possession currently here. All right, so I'll just show you how to use that button. So we have sine A equals 0.5. You literally just think of it as like an equation operation where you're going to do sine inverse as like an operation on both sides. And you're not doing anything on this side. On the left side, you're just sort of canceling it out and saying sine inverse gets rid of sine, so you're left with just A. On the right side, we're actually doing sine inverse. Drop the calculator, sorry if that was loud on your end. Sine inverse of 0.5. So we're going to do second sine or shift and sine or whatever, right? So for me, second sine and then 0.5 equals, or if your calculator is the other way around, you'd hit 0.5 and then hit second sine and it would do sine inverse of 0.5. Okay, and the calculator spits out an answer of 30 degrees. Right, so same idea here. You're going to get rid of cos, you have to do cos -1, cos inverse, right? So second, or shift inverse, whatever, cos of 0.5. So for this one, cos inverse of 0.5 gives us 60 degrees. So just left of a B there, and it spit out 60 degrees for me. And the tan of 0.5 here. So we're going to do tan inverse. Get rid of the tan operation function. Tan is gone, cos is gone, tan's gone. We're left with just C, the actual angle. So tan -1 of 0.5 is 26.56. So 26.6, I guess. Okay. But that actual process is just something you need to know. It's not crazy. It's you need to do it. Right? You have to get rid of sine, cosecant in order to solve for the angle that's sort of trapped inside of the sine, cosecant. Right? And so what we're going to do in the next slide, we're going to end up with that being a process we need to do as we solve for a missing angle. Okay? So yeah, the first step is the same, very similar to before. You have to identify your sides to find out what ratio you're working with. And so way over here on the opposite side of the triangle, we've got opposite, the longest side, opposite the 90 degrees or hypotenuse. And so let's not go up. Right, our side, we love the tail, we've got opposite and hypotenuse. And so, you know, the opposite and hypotenuse can get underlined everywhere. The one that's 2 is your function use, right? So in this question, you can tell that sine of that angle A that we don't know would be equal to the opposite over the hypotenuse. So in this case, the 5 over 12. I'm totally okay with you starting there. I'm just going to communicate a little extra here and point out, of course, this is the opposite over the hypotenuse. The more you communicate that kind of thing, the more chance you have of catching your errors. I've certainly done that where I put the numbers in and then I go to label them and I go, oh, oops, I got it backwards by accident. So you have a chance to notice a mistake and fix it, right? So we just have to get rid of something here. Now, you could actually do one step first. I'll show you that. If you wanted to, you could do sine A, and you just do that 5 over 12. So 5 over 12 is 0.416 repeated. So then at that stage, you know, you do sine inverse of an actual number rather than sine inverse of a fraction. Could be stressful looking or something. But this just gets rid of sine. These with just A and with sine inverse of that number. So it's in my memory, my calculator here. I guess it's sine inverse. I'm just going to go answer the way my calculator works. Do whatever you need. Type in the numbers, whatever. If you get to use know how to use the memory feature on your calculator, it'll make your life a little easier, of course. And that gives us an angle. So it's not feet or meters or whatever this time. It's degrees. Okay, so let's get to put that on. And again, I have a feeling the therefore statement here clearly it's A, the angle A we're looking for is that. They did show it like this, so I suppose you could say therefore, you know, angle A is 24.6 degrees, but the communication value being added there is pretty minimal. Okay. So that one we solve for angle A using sine, and each time you just choose the appropriate ratio, right? They're asking us for angle B. I didn't label it specifically this time, but it did say that, so you should, you know, obviously interpret that's what's going on. Over here we have the hypotenuse of 15. And that would leave this one being the adjacent side. The opposite side's over there. Over here, we're not using it. So just be aware that it's there. We're not using it. And sine, cos, tan selection here. So we have the hypotenuse and the adjacent, right? Hypotenuse and adjacent. So let's bring those notes. So cosine of the missing angle B equals D, and adjacent over the hypotenuse, and so it's the 12 over the 15. It's adjacent. What? Oops. AJ. Try B. Right, so we can calculate the value here. We could do it all in one step. It's not a problem if you do that if you're okay with it. So if you did cos negative inverse like that, you know, you're getting rid of your cosine, so you're having B left over, and then you are just doing 12 divided by 15 in your calculator, you can answer, and then doing second cos of that number. It gives you 36.9. This turns out to be 36.869, blah, 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 right? So 36.9 degrees. Save a little bit of writing or whatever. That's not really that crazy of a thing to skip past. There is old versions of solutions for these things, these other pages. I just leave it like that. sometimes in case someone needs to just use the file without me having a chance to go through it. So if you're wondering why there's duplicates there, it's just the way it is. And example 3, we have to find the measure of angle B. And so we're looking for B again here. So we identify over here on the opposite side. And this is the hypotenuse. We're not using it, but that leaves us going to be the adjacent. So we're using opposite and adjacent. Fine, that's going to be the tan ratio once you get tan. This will not be as necessary to do this every time, but opposite and adjacent. Right, opposite and adjacent everywhere. Tan's got both that we're working with or looking for. And so here we go. One of, oops, that's a C, tan of the angle we're looking for equals opposite over adjacent. In this case, this is 10 over 12. So we're going to get rid of tan. That gets rid of tan, but we're doing it with just angle B. And we're going to do the 10 divided by the 12. 10 divided by 12. And gives us 0.83333. So I'm getting tan inverse of that number. Gives us a 39.8. Okay. So that's the scoop on how to solve for angles. I usually just separate it into a separate lesson just to make sure we can get the hang of the buttons and so on. So the first page is your assigned work for this and practice. Notice in the first question, it's just, well, it's saying that it's, they're looking for you to determine tan of A. I just did question 1A, right? So they're specifying tan of A. So they're already selecting, but you could verify for yourself that it's opposite and adjacent. So that makes sense to do. Use the numbers they gave you. I suppose if they asked you to do sine or cos, you have to find this number first by Pythagorean theorem. And so that's a more in-depth question. It totally could have been asked. But the way it's set up, they gave you the numbers you need. And then it also says determine the value of this. Notice you wouldn't have to determine, like you could go straight to doing this with our new method, basically. So they're saying, what's tan of A? And just calculate it as a separate thing. But I would recommend doing this like we did in the lesson as a separate thing. Just write it down, tan of A equals the number, appropriate ratio of numbers, I'll let you do it. And number 2, it does just say here, which one can be determined using the sine ratio, and then determine the value. And then in 3, it's just more generic. It says, actually, I think it says find the marked angle. Sometimes it'll say just find all the angles. In which case, you don't just determining the A and the B, but they did just say that the A angle, whatever, the T angle, the next one. Notice that we have the skill to solve for everything and anything here. We could use, once we have this angle as a number, we could use adjacent and hypotenuse. We could use cos to figure out the hypotenuse even. That would be called solving the triangle. Right now, we're just sort of, using what we've learned, just missing angle for now, just to give you some bite-sized pieces to learn. All right, so hopefully that helps. Let me know, of course, if you have any questions. I'll save that and post it and all that good stuff. All right, so until next time.